It's not now. These results aren't bad. All of them are what I would consider proficient except for number one. So I'm just going to go over number one with you because you're probably going to see it pretty similar to one like that on your final. Now for you guys, this was all multiple choice practice, right? So the multiple choice for you will be next Tuesday. All right, we'll have a full day on Monday, and on Monday we will do an entire multiple choice practice exam. All right, and then on Tuesday you'll actually take it. So number one, what is the probability of spinning an even number on your first spin and a multiple of 4 on your second spin? I think there's two reasons that kids might get this wrong. The first one being they don't know what a multiple of 4 actually is. 1 is not a multiple of 4, right? 2, they don't realize how many events are actually happening and they think it's overlap. How many events are happening here? How many times am I spinning the wheel? If you're spinning the wheel twice, it's not mutually exclusive, it's not overlap. Mutually exclusive and overlap is a single event. This is independent because more than one thing's happening, okay? So let's start with finding the probability of an even number. All right, so I'm looking at the wheel and I see that there's 1, 2, 3, 4 out of 8 even numbers. And if I map, enter that, I get 1 here, all right? The second event is a multiple of 4. 1 is called a factor of 4. Factors get smaller, multiples get bigger. The smallest multiple of 4 is 4, okay? And then it just gets bigger from there. So our multiples of 4 are 4 and 8. And 12, and 16, and 20, and 24. But on our wheel, there's only 2 of them, 4 and 8. I could see why you think that is an overlap, right? Because I highlighted them in 2 colors, but it's not an overlap because it's not an or problem. Both of these things are going to happen. So it's 2 out of 8, which does end up reducing to 1. So because 2 things are happening, I'm looking to find the probability of even, and was underlined there so that you could see that 2 things were happening. Multiple of 4. I'm going to take those 2 probabilities, 1/2 times 1/4. If 2 events happen, you're multiplying. You can type that in the calculator, but it ends up being more. So I think there's 2 reasons that you could have got that wrong. The idea of like what is a multiple of 4, and the idea of that 2 things are happening, so I need to multiply rather than half. All right. So 1/8 is the answer for that one. The other ones look good. Today I want to finish up our factoring review. We started it yesterday. We're going to finish it today. So yesterday we did A equals 1 and GCF. All right. So today we're going to add in those final 2, and then that'll sum up our review. We're starting the final tomorrow. All right. So if you can take out your your white packets and open them up to page 3. We're going to start with the A is greater than 1 method. You already have the notes filled in for A equals 1 and GCF if you were in class yesterday. If you weren't in class yesterday, they're on Canvas, so you can get those notes on your own time. All right, so A is greater than 1. We use this for 3-term trinomial where the first term is x squared with a number in front. So it's not just x squared, it's like 2x squared or 5x squared, and there's 3 terms, okay? And then how do I do it? There's just like a quick little process there. This one takes a long time, okay? It's the hardest of all the methods because it has the most steps. I tried to keep the explanation brief so you weren't writing a crazy amount. So yesterday we went through and we looked at all 9 examples at the bottom of the page, and we did the GCF and the A equals 1 already, right? They should be completed on the bottom of your page already. So what I'm gonna do here is I'm going to just fill in the answers that we had for that. We'll go back to docs. All right, so I think we have nothing written down for number 1. We had nothing written down for number 2, but when we went to do number 3, we figured out it was a GCF problem and we divided out the 4. No, the 3. So if you don't have this written already, we did that yesterday. And then we realized that this one was A equals 1, and we ended up factoring it and getting this. And we realized that this had a GCF of 2, so we divided out the 2. And then we realized that it was also A equals 1, so we factored that part too. And then we factored this one with A equals 1 as well. So on your paper, you should already have everything that I just wrote. Okay. Which means I have completely factored everything except 1 and 2 here. So if I'm just asking myself, is 1 or 2 A is greater than 1? What do you think? Is 1 or 2 A is greater than 1 method? Why not? They're binomials. I need 3 terms, that's only 2 terms, so I'm not going to use it there. So let's move on. On this page, you should have already done a GCF here. We divided out a 2x. We talked about this part yesterday. And this problem was different. Was it 32? 36. 32x right? Minus 72x. Plus 36? And we divided out of 4. So we got to that point yesterday. That should be already filled out on your paper. Now what I'm looking for today is, are there any A is greater than 1 problem? Is number 8 a trinomial? Yeah. Is A greater than 1? What is A? 6. 6 is greater than 1. So this is an A is greater than 1 problem. So we're going to practice what we preach. We're going to practice what we just wrote down, okay? Step 1 in an A is greater than 1 problem is to do A times C divided by X. So in this case, that would be the 6 times the negative 7. That's what I'm putting in my calculator. So in my calculator is going to be a negative 42 divided by X. And I'm going to look for numbers that add to negative 19. So let's see what we can come up with. Negative 42 divided by X. Looking for a pair of numbers side by side that add to negative 19. Does anybody see a pair on the board? Okay. 2 and negative 21. Now, from here, that process is the same no matter how you do the problem. From here, I showed you 2 different ways to do this problem. Some of you, I called the box method. You create a box, and in the first box is the first term, and in the last box is the last term, and in the 2 remaining boxes is the 2 numbers that we picked. We're just going to make sure we put X's with them. If you're looking at that like you've never seen that before, then that's because you didn't do it that way. The initial way I taught it was you keep the first number the same and the last number the same, and you make that negative 19x of 2x and a negative 21x. And I like the order of 2 and 21 because I like pairing the 21 with the 7. That just kind of makes more sense to me. Alright, so maybe you saw it this way. This is called factor by grouping, and this is called the box method. You will get the same answer no matter which one you use. You use the same numbers, okay? For this method, you're going to group these in pairs, and you're going to divide out their GCF. So I'm looking for the GCF between 6 and 2. You can do that in your calculator. Math, arrow to the right, 9 of 6 and 2. So that's 2. Now, would it be a 2 or a 2x? This has an x, this has an x. If you're doing it this way, you're still taking the GCF of 2x out, you're just doing it with like a graphic organizer. Right, now I'm going to do the GCF between negative 21 and 7. Math, arrow to the right, 9. I can't use the negatives though, so I'm just doing 21 and 7, right? So that GCF is 7, but because the first number's negative, the GCF is negative. It's the same thing here. Neither of these, or this doesn't have an x, so the GCF doesn't have an x. This doesn't have an x, so the GCF doesn't have an x. Same process. This next step's going to look a little different for each method. If you do it this way, you're going to actually do the division. So 6 divided by 2 is 3. X squared divided by x is x. Positive 2x divided by positive 2x is positive 1. You have to put the placeholder there. The 2's cancel out, the x's cancel out, and then I put a 1 there. 2 divided by 2 is 1. And then the GCF goes to the front. Negative 21 divided by negative 7 is 3x. Negative 7 divided by negative 7 is positive 1. And I put the negative 7 in front. I'm going to write this part with this part. And this part with this part. So it's 2x minus 7, 3x plus 1. If you do the box method, you have the 2x minus 7 part. Where the 3x plus 1 part is coming from is the GCF up and down. Math, arrow to the right, 9. GCF of 6x squared and negative 21x is 3x. And the GCF between 2x and 7 is just 1. That's where the 3x plus 1 is coming from. You get the same answer either way.
Doesn't matter. Which one is done?
The 3x plus 1?
In front of the minus 7.
Does not matter. Order to be swapped. Alright, so factor by grouping is a process. It's a long process. I want you guys to try to factor this by grouping before you head out for lunch. Alright, so ignore the 4 that we factored out yesterday. I want you to do the factoring with the 8, the 18, and the 9. I don't care if you do it this way or this way. So my goal would be in the next 6 minutes, because we're out of here at 18, you can factor that by grouping. Alright? So the 8x, the negative 18, and the 9. So you're typing 72 divided by x in your calculator, looking for numbers that add to negative 18, and then going from there. Don't forget at the very end of factor by grouping, your factors will have a 4 in the front because we factored out a GCF of 4 yesterday. All right, my ultimate answer here was 4x minus 3, 2x minus 3. There's all my work. I did it both ways. It's kind of shoved in the bottom there, but. And then I had to put a 4 in the front of that because of the 4 in the beginning. So that's all A is greater than 1. When we get back from lunch, we'll do differences of perfect squares. And then I'll give you some practice time for the final because the final starts tomorrow, all right? You can't leave the classroom till 18 though because lunch A is still going on. So once that changes to 18, you can head out. All right, last factoring method here. Differences of perfect squares. We're back to page 3. We're going to finish it off. Differences of perfect squares. In order to factor with differences of perfect squares, it's got to be 2 terms. Got to be 2 terms. GCF can be 2 terms. DOPS has to be 2 terms. All right. DOPS also has to be subtraction. The D stands for differences, which means subtraction. And the PS stands for perfect squares, so they've got to be perfect squares. Subtraction of perfect squares. 2 of them. You don't have to list all the perfect squares if you don't want to, but if you don't know them, it might be helpful to list them out. All right? Here's how you do it. You take the square root of each term, and then each of those goes in their own set of parentheses. Ryan, focus.
Took my calculator. Yeah. Yeah. I don't think anything.
So I'm going to go back to all the problems that we've already factored, and we're going to pull out the differences of perfect squares ones, and we're going to factor those. So, number 1, we didn't factor at all. That's because it's 2 terms, it's subtraction, and they're both perfect squares. Now, 196 is not like a common perfect square, so if you're not sure if it's a perfect square, you can type it in your calculator. Second x squared will give you a square root. And then 196, the square root of 196 is a whole number, which means that it is a perfect square. So, to factor perfect squares, you're going to take the square root of each of the terms. We just did the square root of 196 and found that that was 14 in the calculator. To do the square root of x squared, what number's on the outside if there isn't one? 2. It's not a 1. It's a square root. And with variables, we do the inside number divided by the outside number. So 2 divided by 2 is 1, and then there's an x. So it's like x to the first, which is just x, right? So in order to factor with perfect squares, you take the square root of each term, and then you're going to create 2 sets of parentheses. Each set of parentheses gets the x and the 14. One of them gets a plus, and one of them gets a minus. Let's do the same idea for the next one. 2 terms. Both terms are perfect squares. So I'll take the square root of 49. If you don't know how to do that, you can go second x squared. The square root of 49 is 7. And we just figured out that the square root of x squared is x. So that square root is 7x. And the square root of 16 is 4. After you take the square root of both terms, you're going to do 2 sets of parentheses. Both of them get a 7x and a 4. One gets a minus, one gets a plus. I wanted to do this in a different order to show you that it doesn't matter if the plus is first or the minus is first, right? You just have to have one of each. Two terms. Both terms are perfect squares. We can deduct to this as well. What's the square root of 4x squared? 2x. What's the square root of 25? 2x plus 5, 2x minus 5. And then that GCF of 3 just stays in the front. So now we factored all of the 9 examples. We did perfect squares here because they were two terms. Both terms were perfect squares. We did GCF here, but GCF ultimately led to perfect squares as well. We did A equals 1 here because it was 3 terms, and the first term was x squared. Same here. And this one was GCF, but that led to A equals 1. On the next page, we did GCF here because they were only 2 terms, but they weren't perfect squares. And then we talked about grouping for these two. On your final tomorrow, the open-ended tomorrow, there is going to be 4 factoring problems, 1 of each type. You've got to know how to do A equals 1, A is greater than 1, grouping, GCF, and DOPS. All right, there are 4 factoring problems, 1 of each type. So, for the rest of class today, I want you to have time to practice for that. And you can practice for that in 2 ways. This is option 1. Option 1 is our test review guide. It's on page 17. Number 12 is all factoring problems. They're mixed up, so you'll have to decide when do you use A equal 1, when do you use GCF, when do you use DOPS, when do you use grouping, and then you factor it. Or if you would rather practice everything that you're going to see tomorrow on the open-ended, the practice open-ended exam is on the backboard. Okay? So problem 1 looks like those first 4. Problem 2 looks like the second 5, and problem 3 looks like those bottom 2. The answer to all of those are underneath them. All right, so you'd have to get up and look at the problem and then get up to check the answer. So you can either work on strictly factoring or a little bit of all of the things that you're going to see tomorrow. We are in here until 26, so that gives you 20 minutes to choose what you are doing. None of the choices I said out loud involve TikTok, games on your phone, or hacky sack though. 20 minutes of factoring, probability, or rational expressions. All right? Got it? Okay, and yes, you can get your phone and listen to music. Okay. This times this. A times 6. And then you'll look for that middle number.